Hi people, in this video we're going to use our knowledge of asymptotic and discontinuous behavior to determine the equation of the functions below. So in question number 1, it says find the equation of a function in this form right here with a vertical asymptote at x equals 4, a horizontal asymptote at y equals 2, and an x-intercept of 5 over 4, 0. So let's first take a look at the fact that we have a vertical asymptote at x equals 4. Well, if we have a vertical asymptote at x equals 4, that means that in this function right here, x cannot equal 4. And the only way that we would have x not able to be equal to 4 is if we have x minus 4 in the denominator. So that means that we are going to have a function in the form at ax minus 5 over some constant times x minus 4. This right here gives us a vertical asymptote of 4. Okay, so that's the first piece of information that's given to us. The second piece of information that's given to us is that we have a horizontal asymptote at y equals 2. Well, the fact that it's y equals a single number and not 0 or like the equation of a line, for example, is because the degree of the numerator is equal to the degree of the denominator. And because the degrees are the same, we can say that the number that the horizontal asymptote is at is equal to the leading coefficient of the numerator divided by the leading coefficient of the denominator. So because we have a horizontal asymptote at y equals 2, we can say that 2 is going to equal this a over this b right here. Neither of which we know. So we don't have enough information to do anything with this right here, right now. Okay, and then we also, the last piece of information that we're given is that there's an x-intercept at 5 over 4, 0. So because we have an x-intercept of 5 over 4, 0, and because the x-intercept comes from the numerator, we can say that this ax minus 5 is going to equal 0. This numerator that we have right here is going to equal 0 when x is equal to 5 over 4. So I can replace this x with 5 over 4 and solve for a. So here, a times 5 over 4 is the same thing as 5 over 4a, and then move the 5 over by adding it equals 5. Multiply both sides by 4, you get 20. Divide both sides by 5, you get a equals 4. So here's our first piece of information that we know for our equation. We now know that f of x is going to have to equal 4x minus 5 all over b times x minus 4. And then lastly, because I know a, I can actually solve for b in this equation right here. A is known, so now every time I see an a, I'm going to replace it with 4, and then now I can solve for b. Multiply both sides by b, I get 2b equals 4, so that means b equals 2. So now I can go ahead and take that information that I figured out here, and I can fill that in here. So now I can say, step 3, that f of x equals 4x minus 5 over 2 times x minus 4, which is the same thing as 4x minus 5 over 2x minus 8. And now, and verify that I did this correctly. So first thing we know is that we have a vertical asymptote at x equals 4. So we'll type in x equals 4. For sure, I have a vertical asymptote there. We also know that we have a horizontal asymptote at y equals 2. For sure, I have a horizontal asymptote here. And then we also know that we have an x-intercept at 5 over 4, 0. 5 over 4 is the same thing as 1.25, so we did good with this. All right, the next question asks us to find the equation of a function that has a hole at x equals 2, a vertical asymptote at x equals negative 5, a horizontal asymptote at y equals 1/2, and a 0 at x equals 2 over 3. So for starters, we know that our function has a hole at x equals 2. So that means that we are going to have a factor of x minus 2 in the numerator and the denominator. We also know that we have a vertical asymptote at x equals -5. So that means that we will have a factor of x plus 5 in the denominator, because this is telling us that x cannot equal -5. Okay? We are also told that we have a horizontal asymptote of 1/2. So what information does this tell us? It tells us that the degree of the numerator is equal to the degree of the denominator. And we also know that the leading coefficient of the numerator divided by the leading coefficient of the denominator is going to be 1/2. And then the last piece of information is that we have a 0 at 2/3. So that means that in the numerator, we're going to have a factor of 3x minus 2. Because again, our zeros are in the numerator. Well, let's put all of this information together. We know, again, that we will have x minus 2 in the numerator and denominator because we have a whole in the numerator and the denominator. We also know that we are going to have a vertical asymptote at x equals -5. We said x plus 5 is going to be a factor in the denominator. I'm going to skip to part D. We know that we have a factor of 3x minus 2 in the numerator because we have a 0 at 2/3. Okay, and then lastly, we have a horizontal asymptote of 1/2. So for starters, in order for us to have a horizontal asymptote of 1/2, the degree of the numerator has to be equal to the degree of the denominator, which is true. The degree of the numerator is second degree, and the degree of the denominator is also second degree. So we're good to go with respect to that. And right now, our leading coefficient in the numerator is going to be 3 because x times 3x is 3x squared. And our leading coefficient in the denominator is going to be 1 because x times x is x squared. So right now our leading coefficients are 3/1, but we want our leading coefficients to be 1/2. So what I could do is I could change this one to a 6, and then 3/6 becomes 1/2. So because I have this 3 already here, I just need to put a 6 in front right here, and then that will be the equation of my function. Let's verify to make sure it's right. Okay, so the first thing that we have to have is a whole at x equals 2. So I'm going to go follow along my graph and see that when x is 2, it's going to be undefined. Okay, we also know that we have to have a vertical asymptote at x equals -5, which if you look at this right here, we for sure have a vertical asymptote at x equals -5. We also have to have a horizontal asymptote at y equals 1/2, which we have as well. We can see that we have a horizontal asymptote at y equals 1/2. And then we also have to have an x-intercept at x equals 2/3, which we do right here. We can clearly see that the x-intercept is 2/3. So we know that we've done this correctly. All right, in our last example, we're going to take a look at some information that's given to us. So for starters, we know that we have 2 vertical asymptotes. So our vertical asymptotes are going to occur at x equals -3 and at x equals +2. So that means that we're going to have a factor of x plus 3 and a factor of x minus 2. Both of these are going to be in the denominator. We also know that we have a x-intercept at 0, 0. We know right here that we have an x-intercept at 0, 0, which means that we are going to have a factor of x We also know that we have a horizontal asymptote at y equals 0. So that means that the degree of the numerator is going to be less than the degree of the denominator. So if I were to start to place some of this information that we got here, we know that x plus 3 and x minus 2 have to be factors in the denominator. We know that x has to be a factor in the numerator. And right now, the degree of the numerator, which is 1, is less than the degree of the denominator, which is 2, which means that we would definitely have an equation of y equals 0. Okay, for the asymptote, excuse me. All right, but the only problem is that we don't know what like the leading coefficient is here, because if it's gonna divide out to give us 0, the leading coefficient could technically really be anything. However, we have to make sure that we figure out what it is specifically for this graph. So I'm gonna plug in, I'm gonna sub in the point that's given to me, which is that it passes through the point 1, -4. Excuse me, 1, -1/4. So here I'm going to plug in -1/4 for y, excuse me, and then I'm going to say a times, and then I'm going to plug in 1 for x, and then in the denominator I'm going to say 1 + 3. Every time I see an x, I'm going to replace it with a 1. So I get -1/4 equals a over 4 times -1. So -1/4 equals, this technically becomes -1/4 a, which means that a is 1. So here we can say for sure that our function is going to be 1x, or I could just simply say x all over x + 3 times x - 2. And I'm good to go for this question. Let me know if you have any questions. Otherwise, that is it for this video. And I hope you have a wonderful day. Bye.